Okay, so applications of lines. So we'll talk about parallel and perpendicular lines, and then secant lines and average rates of change. So two lines are parallel means they have the same slope. Two lines are perpendicular if they meet at right angles. And we have a nice formula for perpendicular lines. If two lines are perpendicular, the product of the slope is -1. So two lines are perpendicular, one has slope m1 and one has slope m2, then m1 times m2 equals -1. Okay, so a little bit of review about how to find point slope equations for a line. So here's a line. We need 2 points. And the points we have are -5, 1. That's this point here. And then this point is 5, 6. The slope, what is the first thing we find? It's the change in y. So 6 minus 1 over 5 minus -5. And that's 5 over 10, because 5 minus 5 minus -5 is 5 plus 10, or 1/2. Right? And remember that slope is change in y over change in x. That means if we go 2 units right, we go up 1 unit. So 2 units right, and we go up 1 unit till we get to that point. 2 units right, up 1 unit, etc. Okay, so that gives me the slope. Point slope form is the next thing we go to. And that formula is y minus y1 equals mx minus x1. So you can take either point. I usually like to take points that don't have negative signs in them. So I'll go y minus 6 equals 1/2, because it's the slope we just calculated, x minus 5. So this is my point slope formula. Slope intercept form is y equals mx plus b. How do I get this? Well, I take this formula and I solve it for y. So y minus 6 equals 1/2 x minus 5 over 2, just distributing that 1/2 here and here. Y equals 1/2 x minus 5/2 plus 6, but getting a common denominator, you know that 6 is 12 over 2, so we get 1/2 x. 12 minus 5 is 7. And so this equation of our line and point slope formula. Okay, y equals 1/2 x plus 7/2. And so here is our line again. So what's the slope intercept form of a line that goes through the point 1, 2 and is parallel to this line? So 1, 2 is here. That's that point. And we want the line that's parallel. And so 2 units up and over. So here's more or less the parallel line. What's the equation of this? Well, to find the equation of the line, we need a point and a slope. We need to know the point is 1, 2, and we know the slope is 1/2, because if they're parallel lines, they have to have the same slope. So if I know the point and the slope, we can use our point slope formula. Right, and then find the slope intercept formula, slope intercept form, we solve this for y. So y equals 1/2 x minus 1/2 plus 2, right? Because distribute the 1/2 and then add a 2 to both sides. And then 2 minus 1/2 is 3/2. And so there's the equation for the line. And the y-intercept is 1.5. Great. So if you've got a line and a point that's not on the line, and you want to find the parallel line, you've got the same slope, you've got the point, so use the slope intercept, not the slope intercept form, the slope point form, because you've got a slope and a point, and then solve for y. Slope intercept form of the line that goes through -1, 1 and is perpendicular to the line above. And remember that the line above is y equals 1/2 x plus 5/2. So perpendicular line if we have two lines that are perpendicular, if you multiply the slopes together, you get -1. So we know 1/2 is the slope of this line, and m2 is the slope we want to find. And so equation becomes 1/2 times m2 equals -1. Multiply both sides by 2. We get the slope of our perpendicular line is -2. Now we know the slope of our perpendicular line is -2. We know a point, -1, 1. So y -1 equals -2x minus -1. So slope intercept form again? No, not slope intercept. Point slope form. Point slope is this. We can tidy that up a little bit. X minus -1 is x plus 1. To find the slope intercept form, we solve this for y. So we get y equals -2x minus 2. That's distributing this -2 to both of those terms. And then we add a 1 to both sides. We get y equals -2x minus 1. So that's our perpendicular line. And if it goes through 1 minus 1, that's this point. And its slope is -2, so it looks like that. So this is the parallel line, y equals 1/2 x plus 3/2. This is the perpendicular line, y equals -2x minus 1. Okay, so that's how we can use perpendicular and find equations of lines that are perpendicular and parallel to a given line. So one question is where does this formula come from anyway? Why should that be true? So why is the slope of a perpendicular line is the negative reciprocal? So if we take a point here that's on the line, and suppose we want to draw a line that's perpendicular to the blue line at this point. We know that this line has a slope of 1/2, which means 2 units to the right and 1 unit up. If we rotate this by 90 degrees to get a perpendicular line, here's my perpendicular line. And I want to find the slope of that. How do I find the slope of that? Well, rotating the blue line 90 degrees, that means if I rotate this triangle 90 degrees, I should get a slope triangle for the perpendicular line. But when I rotate this horizontal part 90 degrees, it becomes this vertical part. And then when I rotate this part 90 degrees, it becomes this horizontal part. So the perpendicular line it's down to right 1, so -2/1. And the slope of the original line is right 2 up 1, so it's 1/2. Right? So by rotating 90 degrees, we're going to switch the top and the bottom, but also by rotating 90 degrees, we introduce a minus sign because if you have a positive slope and then you rotate it 90 degrees, you'll end up with a negative slope. So if the slope of some line is 2/5, what's the slope of the perpendicular line? minus 1/2, minus 5/2, sorry, the negative reciprocal. And don't quote me on whether or not reciprocal is spelled correctly there. So minus 5/2. Okay, so secant lines and average rates of change. So a line always has the same slope. You can always find that triangle to measure the slope. Nonlinear functions have functions that are not lines have different slopes depending on which points you pick on the line. So y equals x squared is graphed on the next page. So we'll go and look at that and we'll find the slopes connecting all these points. So, whoa, that's a little bit too big. So we're going to zoom in a little bit so we can see our picture. Not put it that far. Okay, good enough. So points we're dealing with are minus 1, 1 and 4, 16. Oh, and 2, 4. So these are both points on the graph of the parabola. There's minus 1, 1 and 1, 2, 4 is there. So what's the slope of that line? We pick 2 lines in the 2 points in the parabola. We can draw a line connecting them, and the slope you can see is 3 units right and 3 units up. So 3/3 equals 1. We look at minus 1, 1 and 4, 16. So if I take 2 points on the parabola and I draw the line that connects these two, right? It's a very different slope. We go 1, 2, 3, 4, 5 units right. So there's a 5 on the bottom. And then we go a bunch up. I'm not going to count it, but I know that if I started at height 1 and ended at height 16, that means I went 15 units up. That's 3. So parabolas aren't lines, right? If I pick a point and another point on the parabola, I get one slope. If I pick a point and a different point on the parabola, I get a different slope. And if we take minus 3, 1, 2, 3, 9, and 3, 9, right? Those are both points on the parabola. Then that slope is 0. So big difference between nonlinear functions and linear functions, right? We don't have a really good idea of what slope means for a parabola. But we can pick different points and we can connect them with a line. And this actually has a nice interpretation. These lines are all called secant lines. If you pick a point, 2 points on a graph of a function and connect them, you get something called a secant line. A little bit of terminology there. And the average rate of change of the function between the 2 points is the slope of the secant line connecting those 2 points. So if I start here and I go to here by following the parabola, what's the average rate of change of y? Well, we went up 3 units in 3 units on x. So for every unit of x, we went up 1 unit. So what we've calculated then is the average rate of change of the parabola between points on the parabola. So there's the formula, rate of change of a function. When it says rate of change means slope. Right? And you just finding the slope, and that's change in y over change in x. So how do we find the rate of change of this function between these 2 x coordinates? Well, to find a slope, you need x coordinates and y coordinates. And they tell us what our x's are, minus 3 and 2. And they tell us what the function is, so we can calculate the y values. Minus 3 squared is 9, 2 squared is 4. So now we have 2 points, x1, y1, x2, y2. And so we can find our slope. Change in y is 9 minus 4. Change in x is minus 3 minus 2. 9 minus 4 is 5. Minus 3 minus 2 is minus 5. So minus 1. Okay. So mechanically, it's pretty straightforward. They'll give you the x's. You have to find the y's using the formula, and then you just find the slope. But rates of change are also known as averages, right? So suppose on May 1st, 2016, I weighed 220 pounds, and 90 days later, I weighed 205 pounds. So what was my daily average weight loss? How much did I lose a day? Well, I lost 220 pounds. No, sorry, I lost 15 pounds in 90 days. And you can simplify that a little bit. That's 1/6, I think. So you can think of it as I lost, on average, 1/6 of a pound a day, or you can think of it as I lost a pound every 6 days, right? Roughly a pound a week, 15 pounds in 90 days. Does that mean that I lost that much weight every single day? Well, no, my weight loss, day 0, day 90, over the pandemic, of course, I gained most of that back. Meant that I started at 220, and 90 days later, I was at 205. But my actual weight loss, maybe I gained a little bit, and then I stopped eating, and then I blah, 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 whatever I did, right? And so this is my actual weight loss, but what was the average loss per day? Well, I lost 15 pounds in 90 days, so 1/6 pounds per day. And that's the slope of this line connecting them. And so this line says, if I lost this much every single day, then I would lose 15 pounds in 90 days. But it doesn't tell me exactly how my weight changed. So likewise, we can look at average velocity, right? Notes the units here, right? Pounds per day. Average velocity, rock is thrown up. This is its height after a certain number of seconds. What's its average speed? So, right, you've all thrown things into the air, goes up, and then it comes back down. And we want to know if t equals 1 and t equals 2. This is how much height changed over those seconds. What's its average speed? So t is in seconds, h is in meters. We know that t equals 1 and t equals 2 are the times that we're interested in. And I just need to look up where I had this written down. If you plug in t equals 1 into this formula, you get 17.1. And if you plug in t equals 2, you get 22.4. So what is this telling us? At 1 second after release, it's 17.1 meters in the air. After 2 seconds after release is 22.4 meters in the air. So what's the average speed over that time interval? Well, its final height is 22.4. Its initial height is 17.1, and it was from time t equals 2 to time t equals 1. And so that's 7.3 over 1. And the 7.3 is in meters, and the 1 is in seconds. Right, so 7.3 meters per second is its average speed. And of course, it's not actually going at that speed the whole time, right? When you throw something up into the air and it goes from t equals 1 to t equals 2, it's actually slowing down a little bit. Over that second, that's what its average speed was.